Hi, I'm James Thomas, Application Specialist here at Syngenta, and today I'm going to be talking to you about the importance of controlling drift and how to prevent it. Controlling drift is important because the products you're applying need to reach their intended target. This will ensure maximum efficacy from products, better for profitability and minimum environmental impact. Weather is the key factor when it comes to controlling drift. To check wind speed, a simple anemometer can be used. If one of these isn't available, you can use your surroundings, including the trees, flags, and also smoke. The ideal wind speed for spraying is 1 to 2 meters per second or 3 to 6 kilometers an hour. Spraying in unsuitable conditions significantly increases spray, missing the target and drifting away from the crop. Boom height is the single biggest controllable factor when it comes to preventing drift. Maintaining 50 centimeters above the target will not only ensure minimum drift, but ensure maximum coverage, which will provide excellent efficacy. Even increasing this distance by as little as 30 centimeters to 80 centimeters increases drift by 6 times. A good way to check whether you are maintaining 50 centimeters is to use a Syngenta cable tie. This can be attached to either end of the boom. Boom stability is also key to maintaining 50 centimeters. Regularly checking and servicing your boom suspension can be key to ensuring smooth boom travel. Many modern day sprayers are equipped with boom leveling systems. To ensure these are working correctly, they need to be cleaned and sensitivity set to the correct setting. Forward speed can also have a severe impact on drift. Faster forward speeds mean more turbulence behind the boom, and it is more difficult to control the spray. The energy required to push through the air increases as the square of speed increases. Go twice as fast, you need 4 times the power, or in spraying terms, you generate 4 times the turbulence or drift. For example, drift more than doubles when you go from 8 km an hour to 12 km an hour. The faster you drive, the greater boom instability, which leads to a reduction in even coverage from your nozzles. Nozzle selection can also help us when it comes to controlling drift. There are many different types of nozzles on the market, but air inclusion nozzles have been specifically designed for drift reduction. They work by mixing spray solution with air. This creates large, coarser droplets which are less prone to drift. Flat fan nozzles produce droplets which range from 1 to 500 microns in size. The smaller of these droplets have high velocity when they exit the nozzle, but slow within 10 centimeters of the exit because they have very little momentum. This makes them very susceptible to drift. They also carry such small amounts of spray solution that they offer very little efficacy benefit. Air induction nozzles, however, due to their large droplet size, have a much slower exit velocity, but carry much greater momentum. Therefore, they are less susceptible to drift. Practically, in a field situation, the difference is very noticeable, especially when using 90% drift reducing nozzles. For a drift reducing nozzle to achieve its drift reduction rating, it needs to be operated at the correct boom height and pressure. This information can be found on the manufacturer's website. Setting the correct pressure to achieve the drift reduction rating is important. As can be seen, a drift reduction nozzle operated above its rating produces a much finer spray, which are more susceptible to drift. Many operators are concerned that drift reduction nozzles can lead to a reduction in product efficacy. However, if used correctly in conjunction with the right products and targeted with the right amount of water volume and forward speed, efficacy can be maintained. Syngenta has spent much time investigating this.